So, looking at a predicting products problem from last class, what kind of reaction would this be, and how would you know? Somebody said double replacement. How'd you know? Yeah, good. I'm good. You got two compounds, right? That's a compound. That's a compound. Remember, a compound is when you have two or more different elements, different kinds of atoms together. So if you see two or more different kinds of symbols, that's a compound. Whereas if you see something like O2, that's still an element. It's just a diatomic element. Okay, so we got a compound plus a compound. So that is a double replacement. In double replacement, compound plus compound leads to two different compounds. Where what happens is the two, we call them anions, the things that get negative charges. So here this one's interesting because it's two polyatomic ions. So sulfate, that's a -2 charge. Nitrate, that's a -1. They're going to switch positions. Okay? So what ends up forming is you will have lead now pairing up with nitrate, NO3. And then you're going to have silver now pairing up with SO4. But don't stop there. Some people, they do that and they think they're done. You have to make sure those charges balance out. Now, this one's actually kind of tricky because what is the charge of lead? Lead and tin, if you look at them on the periodic table, they technically aren't part of the transition metals, but they always behave like transition metals. Okay? So then, what charge would it have? You can't assume it's a +4. How would I be able to figure out what charge it'll have?
Because you assume it was balanced in the first place, so it's 2.
Yeah, good Adam. Yeah, you see right here, to get these charges to cancel out, there's a -2 in the sulfate. So here, lead had to have a +2 charge. Okay? So then whenever lead's paired up with nitrate, it carries over that +2 charge. You don't carry over the subscript. Say there's like a 2 on the lead there. You wouldn't carry that 2 over there, but you do carry the charges over. So then nitrate has a -1. So to get those charges to balance out to 0, I would need a second nitrate, a second -1, for everything to balance out with the charges. Now silver and zinc, they're two transition metals that are exceptions in that they always form the same charge. Silver will always form a +1. And let's say you're unsure about that. You could actually figure that out here because you know I have one nitrate and one silver, and I know nitrate's a -1, so silver must be a +1. So then silver has a +1 over here. Sulfate has a -2. So to get those charges to balance out, I would need 2 silver. So it would be Ag2. So you get that second +1. Okay? So those would be your products. And then don't forget to balance. So, and if you whenever you're balancing, if you find yourself unsure of how to get it balanced, like you're kind of going around in circles, check that you wrote down your products right. I'm seeing almost like half of the times when students are like having issues balancing with these, it's really just because they predicted the products wrong. So in a way that can be kind of helpful because it almost helps you check your work. So if you see something funny going on where it doesn't look like it's balancing out, make sure you did your products correctly. All right, so balancing it, we got 1 lead, 1 sulfate, 1 silver, and 1 nitrate in our reactants. In our products, we have 1 lead, we have 1 sulfate, we have 2 silvers, and we have 2 nitrates. So this one's pretty simple, right? Because I got to get these two to be 2, and if I just put a 2 there, we'd be good. So in the formative, the idea would be you just put a 1 there, and then that would be good. So 1, 2, and then you can just type PbNO32 and then Ag2SO4. You don't even have to put a 1 in front of those. Okay. Oh, and then type of reaction. We said that first. Double replacement, DR. Questions on this? Okay. All right. So getting into the new notes. Let me get my cursor over here. Activity series. So here's the idea of the activity series. Get this erased. It only applies to single replacement reactions. sometimes when you're doing a single replacement reaction, I'll write this a little bit bigger up here on the board. That's a little hard to see down there. Let's say you have a reaction Br2 plus FeCl3, and I ask you, hey, predict the products. Normally the ones I've been giving you, you'd be like, oh, okay, well, Br2, bromine forms a positive or a negative charge. What kind of anion? Or I just said it. It forms a negative charge, right? So it is going to switch positions. It's fighting with the other anion, the thing that also forms a negative charge. So it's fighting with chlorine. And so normally, how I've been showing you, you would then swap these, and you would get Fe will now pair up with Br. So you get Br3, and then Cl will be by itself. That's Cl2. That's how you would normally do these. But technically, when you're doing these reactions, what we're assuming is that iron would rather be paired up with bromine rather than chlorine. Think of it this way, I've been married for a long time, and I like to think that, my wife loves me, and we got a good marriage and stuff. Let's say we're at a party, and, let's say, Pete Davidson's there. I'm not really worried about Pete Davidson, catch my wife's eye, but, who's the big heartthrob nowadays, Is it still Justin Bieber? Who's that? Harry Styles. Harry Styles walks in, I might be getting a little insecure, right? It's like, Harry Styles is in the room, maybe we should go over here, honey, It's like, here's bromine. Bromine's right here, right? Bromine, this is like Pete Davidson. And I'm chlorine, right? Chlorine is me. I'm not worried about Pete Davidson, right? Pete Davidson is not taking my wife from me. But, Harry Styles comes in, I kind of understand it, right? I kind of understand where she's coming from, where it's like, I could be with Harry Styles, not Mr. Blackford, If I wrote this reaction where it was now Harry Styles, and then it's me, it's like, that reaction's probably going to happen. So what I'm getting at is, there is something called an activity series, which says that this reaction technically doesn't happen. This is no reaction, because if you're iron, iron is more attracted to chlorine than it is bromine, right? My wife is more attracted to me than Pete Davidson, right? Iron has why would iron want to be with bromine? It makes no sense, okay? And how you know that is, and I give you this chart. On the test, I would keep this chart up there for you. You don't have to memorize that, so it's kind of nice. You just look up there at the chart, whichever one is lower. If you look at the one that's in the compound, so chlorine's in the compound, chlorine is higher than the element by itself, bromine, so you say, oh, okay, so no reaction. If, like in this example, you have fluorine is higher up than the thing in the compound, chlorine, then you would say, oh, okay, that reaction will happen, and you predict the products just like you have been doing. That's all an activity series is. Okay? So let's look at another example here. So here they're giving us, I'll write a little bit bigger up here, Pb plus AlCl3. So the first step is, thank you, look at the thing by itself. So lead, that's the element by itself. Ask yourself, does that thing by itself, does it give it a positive charge or a negative charge? What kind of ion does it form? So lead, does it form a positive charge or a negative charge? Be positive, right? So lead is competing with the other thing that forms a positive charge, aluminum. So then look at your activity series, find lead. Here's lead. Find the thing in the compound, aluminum. So notice how lead is farther down than aluminum on the activity series. This means that aluminum is more reactive than lead. So if you're chlorine, why would chlorine want to react with lead when it can be with aluminum? Again, why would my wife want to be with Pete Davidson when she could be with me? Doesn't make any sense. Do we still know who Pete Davidson is? Is he still making the rounds? He's good for him, you know. I got nothing against the guy. Okay. Now let's look at two other examples here. So we have really the same problem. You have aluminum plus PbCl2. First question you ask yourself is the thing that the element by itself, in this case aluminum, is that form a positive or a negative charge? Aluminum forms a positive charge, so you're comparing it with the other positive charge, comparing it with lead. Go to your activity series. You have aluminum here, lead there. So aluminum is more reactive than lead. So aluminum is going to kick out lead, and you're now going to get aluminum pairing up with chlorine, and then lead is going to be by itself. But then stop. Make sure the charges balance out here. Aluminum is a +3 charge. Chlorine's a -1. So it's AlCl3. You need 3 chlorines for that to balance out. Okay? Lead is just, you don't say like Pb2 because that's not diatomic. Okay? All right. Looking at our second one. Then you got to balance. I'm sorry. Make sure we do that. So we got 1 aluminum, 1 lead, 2. I was like, why do I have so much space between these? And that's why. Products, we got 1 aluminum, 1 lead, and 3 chlorines. So I got to fix my chlorines. Let's say I triple it. Let's try that. So I give myself 3 leads and 6 chlorines. So now coming over here, my chlorines aren't good. I would need to double my AlCl3, and then that would fix those. And then if I triple my lead, we'd be all good. Oh, almost. Double the Al. So 2, 3, 2, 3. 2, 3, yeah, 2. Okay. All right. Looking at the last one, Cl2 plus FeBr3. So focus on the element by itself, chlorine. Ask yourself, yeah, what's up?
Sorry, so if the element is higher up on the list, that's what wants to be switched? Like, switch it if it's higher up?
Yes, if so, aluminum, the reaction happened here because aluminum is higher up. It's more reactive than the thing in the compound, which was lead. So lead here was part of the compound with chlorine. So it is going to then switch with aluminum. The reaction will happen like you have been predicting.
So the one by itself is the one that would be higher up?
Yes. You look at the one by itself, that's how you know then which one to focus on in the compound. And that's how you know which two you're comparing. Yeah?
How is there a CL3 CL2?
So here, Cl2, what they're saying is you're assuming lead is a +2 charge. So then when chlorine is pairing up with aluminum, aluminum is a +3 charge. So that's why it'd be Cl3.
Yeah, I'm good.
That's good. We good here? All right, let's do another one. So Cl2, chlorine. First question, ask yourself, does it make a negative or a positive charge? It makes a negative charge, yeah? Yeah, good. Okay, so that means it's competing with the thing in the compound that also makes a negative charge. So these are the two things you're comparing, chlorine and bromine. If chlorine is higher up on the list, meaning it's more reactive than bromine, it's more attractive to iron than bromine, iron would then leave bromine for chlorine. So come back here, you see that chlorine is higher up on the list than bromine, so that means iron's like, oh hey, how you doing, right? And it's going to swap out with bromine. Okay? If it was the opposite, right? If this was bromine, that was chlorine, there'd be no reaction. So for your products, you would get Fe paired with Cl, and then you're going to get Br by itself. Remember, bromine is diatomic. Okay? Now, am I done here? No. You got to balance. You got to balance the charges and balance the equation. So here, what charge would iron have? Iron's a transition metal, so you don't see it like written on the periodic table. Yeah, good, 3. It's a +3 because bromine's a -1, and there are 3 bromines. So that means you need, it would be Cl3 because chlorine is also a -1. Okay? And then finishing off by balancing, you would have 2 chlorines, 1 iron, 3 bromines. Products, we got 3 chlorines, 1 iron, and 2 bromines. So let's say we fix our chlorines. Let's try to get them to 6. Okay? And then if I were to come over here, if I double FeCl3, that would get our chlorines all figured out. Let's fix my my iron. So if I double that, I would get 2 Fe and 6 bromines. And then if I come over here, it's another 2, 3, 2, 3. That'll give you 6 bromines. Okay. Is that it? That's it. All right. So I'll let you start working on the formative. Let me know if you got questions.